Now let's start to graph linear equations using intercepts. Now there's many ways to graph a line, and we're going to talk about a few, but the first one we're going to talk about is graphing using intercepts. Let's start off with something simple. Say we have the equation 2x minus y equals 10. And I'm going to ask you two questions about the same problem. The question wants to know, are the following points, your first one A and your second one B, solutions for this equation? The only way that we can find that out is by using what we previously learned about evaluating, which is plugging it in, and see what we get. So coordinate points, as I already told you, the first number is an x and the second one is a y. So when I come over to the equation to plug them in, I want to make sure I put them in the right spot. So here I'm going to get 2 times x, and looking at my coordinate, x is 2, minus y, and y happens to be negative 6. Notice when I plug the numbers in, I used parentheses. The equation had a minus sign in it, and I plugged in a negative number. So you have to make sure you have both. Now I'm going to start to simplify. 2 times 2 is 4. This negative makes this negative a positive, so I have plus 6 equals 10, and 4 plus 6 is 10. So is this a true statement? Does 10 equal 10? Yes, it does. So that means yes, this point is a solution for that equation. Now let's take the same exact equation and check the second point, which is given to us, x is 10 and y is negative 10. So this time it's going to be 2 times 10 minus, and I'm plugging in a negative number, so notice both negative signs, equals 10. Now 2 times 10 is 20. Again, this negative makes this negative a plus, so I have plus 10. 20 plus 10 is 30, equals 10. Now is this a true statement? Does 30 equal 10? No, it does not. So this is not a solution. So we're starting with basically how do we check to see if it's right. So let's take that concept and add a little something to it. So let's try another example. We have y equals 2x plus 3. Now this is a linear equation, which means if I were to graph this, it would be a straight line. But in order to graph it, I have to know what are the points on the line. So there's a method that we use. We call it a table method. And what we're going to do is we're going to start off with the given points. Let's say that they gave us, and I'm only going to choose 3 because you really only need 3 lines to make a good line. I'm going to choose x is negative 2, x is 0, and x is positive 2. Okay? So what we're going to do is we're going to take the same equation 3 times. And basically we're going to do it the first time plugging in x is negative 2, and we're going to figure out what y is. And we're going to go down the page just like that. So let's do the first one. The first one, x is negative 2. So y equals 2. I'm plugging in negative 2 plus 3. And here I'm just going to simplify. Y equals negative 4 plus 3. And negative 4 plus 3 really equals negative 1. So when x is negative 2, y is negative 1. And that is my first coordinate point. Let's do the same exact equation, but with my second option. This time it says x is 0. So y equals 2 times 0 plus 3. Anything times 0 is 0, so I end up with y equals 3. So here's my second point. When x is 0, y is 3. Notice I'm writing the answers as a coordinate point after I plug them into the chart. Now the third one, last but not least, this time x is a positive 2. So I'm going to have y equals 2 times positive 2 plus 3. 2 times 2 is 4 plus 3, so I get y equals 7. So on this one, when x is positive 2, y is 7, and that's my third point. Now, to check myself, basically, if I plot these points and I'm correct, they should make a straight line. Now, I'm not using graphing paper, so bear with me. I'm not a perfect artist. So my first point is -2, -1. So let's go over -2 and then go down to 1. There's my first point. My second point is 0, 3. So x is 0, which means I'm going to stay right in the middle. And y is 3, so I'm going to go up to number 3 on the y-axis. And then my third point, x is 2 and y is 7. So I'm going to go up 1, 2, 3, 4, 5, 6. Let me extend my line a little bit. 7 and over 2. So my line would be about here. And as you can see, you see how straight my points lined up even though I'm not using graphing paper? That's because I know I did all my math right. Because if you plug in the numbers correctly, your points should make a straight line because you use the same equation over and over again. Let's do another example, but with some different variables. Let's try 2x minus 3y equals 12. But this time, I'm going to mix it up a little. Last time, I only gave you the value for x, and we were always solving for y. But this time, I'm going to give you an x value, I'm going to give you a y value, and I'm going to pick one more because it's always good to have 3 numbers. Okay? So let's try this. Now again, I have 3 numbers, 1 equation, so I'm going to take the same equation 3 times. And I have to substitute in those different numbers that I chose. Okay? So for the first one, I chose x is 0. So let's plug that in. 2 times 0 minus 3y equals 12. Anything times 0 is 0. So I'm left with -3y equals 12. And how do you solve for y? You divide by -3. So I get y equals a positive divided by a negative is a -4. So when x is 0, y is -4. Now for the second one, I have y is 0. So this time I'm going to leave x alone and I'm going to plug in y is 0. Again, anything times 0 is 0. So I get 2x equals 12. And to get x by itself, you have to divide by 2. So x equals 6. So here where y is 0, x is 6. And let's just do the last one. Here I have x equals 2. So let's try this one. 2 times x, which is 2, minus a 3y equals 12. 2 times 2 is 4, minus 3y equals 12. Got to get the 4 on the other side, so it's minus 4. I have -3y equals 12 minus 4 is 8. To get y by itself, I'm going to divide by -3. So y equals, and again, 8 divided by -3, even though it's improper, it's a perfectly fine answer, but for the sake of graphing, we want to change this to a mixed number. So 3 goes into 8 2 times, so I get a -2. The remainder is 2 over 3. So I know that this point is going to be somewhere in between 2 and 3. So now I have my 3 points, 0, -4, 6, 0, and 2, -2 and 2/3. Now don't assume just because you got a fraction as an answer that you're wrong. It can be a fraction. Things are not always whole numbers. So here's my graph. I'm going to take one point at a time. My first point is 0, -4, so x is 0. I'm not going to move left or right, but y is -4, so I'm going to go down 4 and plot my point right on the axis. So my second point, x is 6, 1, 2, 3, 4, 5, 6, and y is 0, so I'm going to plot that right on the point. And my very last one, x is 2, and y is -2 and 2/3. So let's think about it. If this is -2 and this is -3, Negative 2 and 2/3 has to be somewhere in between here. Now again, I'm not using graphing paper, so it won't be exact, but so we'll go over 2 and I'll go down negative 2, and 2/3 of the way is like almost at the 3. So it's in between those lines. And as you can see again, even though I'm not using graphing paper and I got a fraction as an answer, they're pretty straight. They pretty much line up pretty good. So I'll know that I'm doing this problem wrong if I end up with a point way out here. If all my points are lining up in a straight line and then all of a sudden I have this point way out here, chances are I need to go back and check my math on that point, because they should all line up when I'm using the same equation over and over again. Let's try another one. Except this time, let's just say the book or the problem or the test did not give us any values. What would you do? Well, the funny thing is you get to actually choose your numbers. So if they don't give you any, you should choose some. And again, there's some things you want to keep in mind. You want to choose at least 3 numbers. You also, I typically like to always at least choose x is 0 for one and y is 0 for another, because those are pretty easy to simplify when you're especially being timed on a test. Also, I try to pick one positive and one negative number, and that's just to make sure you get a good graph. You want to get both sides of the graph. So I'm going to choose x is 0, y is 0, and since I really only need 3, I'm going to go ahead and pick negative 2. Okay? Notice I chose x is 0, y is 0, and then I went back to x. It really doesn't matter which numbers you choose. You just have to plug them in accordingly. Okay? So again, I picked 3 numbers. I'm going to write the same equation 3 times. And I'm just going to do what I picked. I picked x is 0 for the first one. So 2, plug in the 0, plus 4. Anything times 0 is 0, so I get y equals 4. So my first point is 0, 4. The second one I chose y is 0, so I'm going to put 0 here. I get 2x plus 4. To get x by itself, I need to bring 4 to the other side by doing the opposite. So I get negative 4 equals 2x. To get x by itself, you're going to divide by 2. So x equals negative 2. So when y is 0, x is negative 2. There's my second point. And last but not least, I picked, now look what happened. I chose negative 2 as x, but I can see from above I already did that one. So when I plug in negative 2 here, I'm going to get 0. So I need to choose a different one. So let's choose positive 2 and see what happens. So now I'm going to plug in x is positive 2. So I have y equals 2 times positive 2 equals 4. 2 times 2 is 4. Oops, plus 4. So y equals 8. So when x is positive 2, y is 8. There's my third point. So again, let's take our graph and plot these points. And I'll know that I'm right if they line up pretty good, nice and straight. So for the first one, x is 4, or x is 0, so I'm not going to move left or right. And y is 4, so I'm going to go up to the 4. For the second one, x is negative 2, and y is 0, so I'm not going to go up or down. There's my point. And for the third one, x is positive 2, and we're going to go up 8 on the y-axis. So 1, 2, 3, 4, 5, 6. Extend my line a little bit. 7, 8. So I have x is 2 and y is 8. And again, as you can see, they lined up pretty good. Let's do another one. Let's do 2x minus 4y equals 6. Again, it's always good to choose at least 3 numbers. I always like to choose 0 for x and 0 for y. and one extra number. Okay, let's try this one. So, I'm going to write my equation 3 times. And the first time I picked x is 0, so 2 times 0 minus 4y equals 6. That equals 0. Negative 4y equals 6. To get y by itself, divide by negative 4. Y equals, and we're going to simplify this. So 6 over negative 4, I can simplify it by 2. So I can get 3 over negative 2. And again, for the sake of graphing, we're going to make this a mixed number, which will be negative 1 and 1/2. So when x is 0, y is negative 1 and 1/2. Let's do it again, but this time we're going to make y 0. So I get 2x minus 4 times 0 equals 6. That cancels. I'm left with 2x equals 6. To get x by itself, you have to divide by 2. To get x equals 3. So when y is 0, x is 3. And then one last time, this time I chose x is 6. And I typically really don't go over 5 or 6. When you start picking large numbers, it gets too big. And then it goes off the page. You don't have enough graphing room. So here I'm going to do 2 times x, which is 6, minus 4y equals 6. 2 times 6 is 12, minus 4y equals 6. I have to move this 12 to the other side. So I get negative 4y equals negative 6. To get y by itself, I'm going to divide by negative 4. So I get y equals, now negative divided by negative gives me a positive 6 over 4. But this is just like the other one, so I'm going to end up getting a positive 1/2. So when x is 6, y is a positive 1/2. Now we're going to graph it. Okay, so when x is 0, I'm not going to move left or right, but y is negative 1/2. So here's negative 1, here's negative 2. So negative 1/2 must be somewhere in the middle. And the next one, x is 3, and y is 0. So I'm going to stay right on the x-axis. And the last one, x is 6. So I have 3, 4, 5, 6, and y is positive 1/2. So here's positive 1, positive 2. That means positive 1/2 is somewhere in between 1 and 2. So I'm going to go 1.5. And again, I know that I did a pretty good job because my points are lining up pretty nicely.